Hello and welcome to our webinar on the Introduction to Bluetooth Low Energy Audio. My name is Finn Boetius. I'm a product marketing engineer at Nordic Semiconductor. I'll be hosting this webinar, and with me I have Eirik Midtun, who's our technical product manager and knows everything about Bluetooth Low Energy Audio. Before we get to the actual content of this webinar, let me just tell you what you can expect here. So the overall duration will be 60 minutes. Questions are highly encouraged. You can type those questions in the top right of your sidebar. There you will see a box as you can see here now on screen. All questions are anonymous, and please try to keep them relevant to the topic. We will answer the questions towards the end. The chat is not anonymous. You are very welcome to use it, but people will be able to see your name. If you have any more questions, or we had some questions that couldn't have been answered, you're always welcome to check in with us on DevZone. We will have a recording of this webinar available after the presentation at nordicsemi.com. This usually takes about a day. The webinar itself will be 45 minutes and then 15 minutes Q&A. Yes, and with that, let me give the screen and the mic to Eirik to tell you what you came here to know.
Hello and welcome to a webinar on Bluetooth LE audio. My name is Eirik Midtun and I'm the Technical Product Manager for Bluetooth at Nordic Semiconductor. For this webinar, we will cover the basics of the new LE audio standard and explain the reasons for why it was made. We'll explain to you new features in the LE audio standard, and we'll present the SoCs, tools and software that we offer from Nordic Semiconductor to get you started. LE audio is the next generation of Bluetooth audio. So now Bluetooth audio comes in two flavors. It's the one that was from the beginning, that we now call classic audio, and there's a new specification called LE audio. In the solution space, we still have the classic audio and it will continue to live. But we believe that the future is in LE audio, and that is where Nordic will put in its effort, since we are a Bluetooth LE focused company. There will also be a solution that combines the two specifications, classic plus LE, and we think this will be valuable in the transition phase, but eventually this will be phased out and LE audio will be the future. Before we start talking about LE audio and their advantages, I will say something about Bluetooth audio, classic audio solutions, in order to understand how they're designed and what are the advantages with LE audio over the Bluetooth classic audio. Here you see three profiles, which are the popular ones in Bluetooth classic audio. It's the A2DP, Advanced Audio Distribution Profile, which gives you stereo audio streaming. It's a hands-free profile, which is used for two-way mono audio, and the audio video remote control profile, AVRCP, which gives you play, pause, and volume control, for example. So these profiles are very useful for the use cases, but they're also monolithic. It's really hard to expand on them, and new products typically need to combine them. And you see that on the next slide. You will see a very specific example. So say you have a headset that you use for your computer that can be used both for listening to music and to take phone calls or Teams calls and whatever you use. This headset will actually show up as two different devices. So on top you see the hands-free profile, and on the bottom you'll see the stereo headset. So on the first one you get the features you need for the phone call, but the quality is worse. On the stereo you have good quality, but that only supports one direction. So when you receive the phone call, you're back to the top. Since the classic audio profiles were specified, there's been a lot of interesting things happening in consumer audio, and I wanted to illustrate a few points here on this slide with various products. So headsets, for example, they support both listening to music and hands-free profile, and I myself, for example, I use it with not one device but two devices. my computer and my cell phone. So I make two connections and not a single point-to-point. Earbuds is the same, though I use them mostly on my phone, and I think it's really tempting to buy a watch that can store music, and I can use that for running, for example, if I don't want to carry the phone with me. And I also have a speaker that I use. Speakers and headsets now support voice assistant, and there's no profile for that in classic audio, and it's a bit difficult to imagine where it would fit. But manufacturers have gotten around that, as they have solved the problem of connecting to more than one device. But many products, they limit the connections to two. So if you want to connect to a third device, you have to abandon the link to one of the previous products. Earbuds, they are untethered. There's one in each ear. This is also not supported by the SIG standard. It only supports point-to-point. But manufacturers have gotten around this problem, and they have a way where they transmit to one earbud, and there's a proprietary link between the right earbud and left one. So they made it work, but wouldn't it be great if the standard could solve all these problems for you? So this brings us to LE Audio, the new audio standard that covers all existing use cases, provides greater flexibility for product makers, and allow new use cases that wasn't even possible with classic audio. LE Audio comprises some new standards, mainly the Isochronous Channels, which is part of the Bluetooth LE controller, the LC3 codec, and the audio profiles. So this diagram explains the architecture of LE Audio solutions, and it's important to understand how things are designed and how they differ from classic audio. So the first thing is the division of the audio data plane and the control plane. Audio data plane is a path of the audio data. So you transmit or receive uncompressed audio, which goes to other chips for rendering or capturing. And this goes to the LC3 codec, which is new. So this one is configurable and it supports all use cases. And it's a common one that is used for all use cases. So there's no separate codec as we had in classic audio. The LC3 codec can be used for everything. The LC3 codec compresses the audio or decompresses it, depending on which way, and the compressed audio data is transmitted over isochronous channels. The audio profile are GATT profile, so if you're already familiar with Bluetooth LE development, that would be familiar to you. There's a common audio framework which contains a bulk of the functionality. And then there are use case profiles which are fairly light and use case specific, but they build on a common audio framework or generic audio framework which contains all the bits and pieces that are common for most audio product. These goes over a normal ACL channel, which is the Bluetooth LE, the Bluetooth LE transmission that you used from before, which goes point to point. Bluetooth LE isochronous channel is a feature from the Bluetooth core specification, and it was introduced in Bluetooth 5.2. The feature is used to transmit time-bound data needing synchronized processing. This is a generic description of what this happens when you transmit audio data. Audio data is a stream of packets that needs to be rendered at a specific time. Time-bound means that if you transmit and retransmit and it doesn't arrive after a certain amount of time, there will be a gap and a buffer on the receiving end, and you have to deal with it accordingly. For a single packet, you can use packet loss concealment to conceal the fact that you missed data, and if it's several packets, you might have to just declare link loss and disconnect. So that's about the time bounding and the principle that data is only valid for a certain amount of time. Then the next bullet is about synchronized processing. And the earbuds on the pictures illustrate why this is relevant. When you receive audio in earbuds, you need to make sure that they're rendered at exactly the same time with extremely low jitter. And isochronous channel includes features to both synchronized to the clocks to the transmitter, and the profile includes features to make sure they're rendered at exactly the same time. There was an equivalent of this as classic audio for audio. Bluetooth LE didn't have it before 502. But the new thing about the isochronous channel, which is does not exist for classic audio, is that the isochronous channel works in both connected and connectionless mode. Let's have a look at how this feature is used in the case of LE audio earbuds. I've used the vocabulary from the common audio profile, where the phone is referred to as an initiator, where you can something to connect to, and acceptors that can receive an audio stream. So the earbuds, we have a left earbud and a right earbud. These will be connected with ACL, which is asynchronous connection-oriented logical transfer, and also known as the normal Bluetooth LE connection. And this connection is more or less permanent, and it's also very low power, as we know from working with Bluetooth LE technology. This is another advantage, by the way. It gives you very low standby current, and you can also control your earbuds through these channels. So as I showed on the previous slide, ACL is what you do in the control plane. CIS, that's a connected isochronous stream or group. Those are channels that are being established when there is audio on the channel. So when you hit play on the mobile phone and want to listen to music on the earbud, that is when those CIS connections are established. And CIS, we have a left and right earbud that play a stereo sound. Those are connected as part of a group where you can synchronize the CIS connections or the streams. Each stream will contain the audio mono stream, so there's a mono left and mono right, and these will be kept alive for as long as you listen to music. If you stop music, they will tear down the connection and go back to the pure ACL connection, which will give you the low standby current. The next addition to the LE audio standard is LC3, the low complexity communication codec. This is a new codec that is required for LE audio products. You can use other codecs if both sides implemented. That is allowed as before. But this is basically a replacement for the SBC that was the required codec for Bluetooth Classic. As you can see, the audio quality is a lot better. You can see in the blue bars that you hit a near perfect score on perceived audio tests. Not only is it better, but it remains better even at lower bit rates. So for even low bit rates, you get better quality than SBC, which means you send less data, which means also you consume less energy. The sample rate goes from 8 kHz up to 48 kHz, and the data rate can be set from 16 up to 320 kilobits per second per channel for the maximum quality. One question I get a lot when it comes to the LC3 codec is about the quality, like how do you test it? How good is it? And there's something better that you can use to differentiate from competitors. So that's the first one. These perceptive scores are done by subjective listening tests. So the actual people listening to different audio samples that are being encoded by different codecs with different settings. And the subjects are asked to rate them, and also to find out what are the reference signal and rate the reference signal. And what these tests found, this graph is from a report in a paper called LC3 and LC3+, the new audio transmission standard for wireless communication. They found that LC3 was nearly imperceptible from a reference signal. You see a reference to the left, we got a score about 4.82. So it's not a reference, does not meet max of 5, it's 4.82, which is slightly better than the best LC3, which was 4.8. So if you cannot perceive any difference, do we really need alternative codecs? Certainly an argument can be made that you can differentiate on this, but it will also increase the complexity, and it will certainly make products easier if LC3 can cover all needs, and people will trust that. The last new addition to LE Audio are the Bluetooth LE Audio profiles, which there are many, but most of them are part of the generic audio framework. And I grouped it in a way that makes it slightly easier to understand and remember what it is. So there is the basic audio profile and the related services below, the media control profile and service, call control profile and telephony bearer service are related to phone calls. Then there is the coordinated set identification profile and service, and there's a microphone profile and service, and there's a voice control, volume control profile and related services. On top of this is also common audio profile, which binds them together, and this forms the generic audio framework. On top of this, there is application level profile. So there's telephony and media access profile, is the hearing access profile and service, and the public broadcast profile, which are smaller profiles that builds on top of the generic audio framework. This slide is to give you a brief overview of the basic audio profile. I'll not go into a lot of detail, but this should give you an idea of what features are supported by this profile and what they're used for. The basic audio profile, which is typically implemented on the phone side. That one allows you to configure codec, configure quality service, and control streaming. PAX is the published audio capability service, and that is where you declare supported audio configuration. There's audio context, like what type of audio are you talking about? That could be if it's a ringtone, or if it's music, or it's a conversation. And audio location, which in this, which for this example of earbuds would be left or right earbud. Then there is the audio stream control service, where you have the audio stream endpoints. So it will tell you if it's a sink or a source. On the earbud, it will be for sure a sink, but maybe a source also if it has a microphone, and it will contain a configuration and which state it is in. Does it stream or not, for example? The coordinated set identification profile service is a new service and profile which stands for need to synchronize independent devices. And as you know, this was not possible before, but now you need to first of all identify members of coordinated set, for example, the left and the right earbud. And it ensures, for example, that if you want to mute your music or control volume, it applies that setting to all the devices in the same set at the same time. So if you do volume up, for example, you will hear the volume going up in both earbuds and not first the left and then the right, which will be annoying. It also ensures that all devices use the same audio source, and that can be a device, but also a use case. So, for example, if you listen to music and receive a phone call, this is the one that will ensure that you're not listening to music in one ear and a voice in the other ear. And one last thing, it's also lock access from other devices when it's in use. So if you have one earbud configured in a set, and it's accessible from phone, the access of the other one is restricted to the same source. So for actual products, these profiles and services will be combined to fulfill a certain use case. For example, if you listen to music on your phone, it's a basic audio profile that does most of the work when it comes to streaming audio and setting up connection and so forth. So that's the one that's being used. You use the volume control service and profile to control the volume, which you see on top, and then you have the media control service and profile, which will be the remote features that you see on the bottom of this figure. Now let's say you listen to music and you receive a phone call. What is interesting now is first of all that you can change some profile that comes into play, but not all. It's still a basic audio profile that will control quality of service, codec settings, and so on. That's still the same. You still have the same volume control, but now there's also audio input control service that's being used for audio. There's a microphone control service that will come into play, which basically allows you to mute your own microphone. And then the telephony bearer service and call control profile will be used to things like accepting call and being in a call state, putting a call on hold, and so forth. So two different use cases served by a selection of various profiles in the generic audio framework. But some are the same, some are different, but it gives you a powerful toolbox for designing various products. LE Audio also introduced a new feature, which is called broadcast audio. And this one is based on Isochronous Channels working in connectionless mode, which is based on advertising extensions. It allows you to broadcast audio to an unlimited number of receiving devices. This can give you location-based audio sharing, which could be private, such as you showing a movie on an iPad and you want to have a friend listening to the same audio through their own headset, or it could be public. So say the TV at the gym that is usually where they usually turn the audio off. Now, with a Bluetooth LE audio enabled headset, you can transmit the audio over Bluetooth LE, and people who want to listen to the sound can tune into to the TV and listen to the audio. People using hearing aids might know this feature from the induction loop, and the goal is actually to replace the big magnetic coil with a simple Bluetooth transmitter to give the same feature at higher quality and lower cost. On this slide, I want to highlight two problems with audio broadcast and the suggestion solution by Bluetooth SIGA and Nordic. So first of all, with a headset or hearing aid or audio product that has a limited user interface, how do you decide what you want to listen to in broadcast mode, and how do you find sources? And the answer to that is that you will need some type of assistant, broadcast assistant, and that could be a phone with an app or native support, and the phone will scan for various broadcasts and find them, and it will display a list of them on the screen, and you can choose from there what you want to listen to. Which brings us to a second problem. If you want to scan for broadcast, that is quite a relatively power-hungry operation compared to the batteries, for example, on a hearing aid. So most likely you will rely on some type of system to actually benefit from this feature. The phone can scan, show the broadcast, and then through the ACL connection, you can transmit the broadcast information to your hearing aid or headset. And from there, the receiving device will know how to follow the periodic advertising to listen to a continuous audio stream at low power. So this topology is worth keeping in mind, that the LE audio is intended to work with assistance, which can be used for many other things, but it will be an important part of an LE audio solution. I have now given a brief introduction to LE audio assisted technology, and now I will talk a bit about what Nordic can offer for this technology. nRF5340 has some very unique features that is absolutely required for some of the use cases in LE audio, and it's also a very flexible platform that allows you to design many different products. Here we have a block diagram of the nRF5340 SoC, which we consider the ideal part for LE audio applications, and it's the only part we support for our audio solutions. We highlighted the key features here. So starting from the right, we have the network processor with our lowest power multi-protocol 2.4 GHz radio. At least on the earbud side, you will receive a lot of data during streaming, and you will really see a difference here compared to, for example, the 52 series. It will also do work quite intensively, so it really benefits from having its own core, which can run purely on the lower levels of the Bluetooth stack. On the application process side, we have a 128 MHz processor, which is powerful to run the LC3 codec at the highest quality, and it can cover enough streams to run most use cases. I2S and PDM are the two audio interfaces that we use, among many other interfaces that can be used for other features in the product. There's also a new PLL in the system, the audio PLL. This was designed with LE audio in mind, and it allows you to tune the clock to receiving RF packets, in particular the isochronous channel anchor points, which is used to synchronize several receivers. So this allows you to play back audio over the I2S with extremely low jitter between two receiving devices. And it's ultimately what allows the true wireless stereo to be implemented. In an audio system, the nRF5340 needs to be coupled with an appropriate audio chip. This allows for a very flexible platform where the LE audio parts are more or less fixed, but you can swap the audio part for according to your use case. The nRF5340 DK, which I will present in the following slides, is based on a series logic part, the CS47L63, which is a mono DAC within its own DSP that is used for sound improvements. The audio DK also has a microphone that is connected directly to the 5340. So this is a system design which is adapted to an earbud, and that's where this series logic part is designed for. However, if you want to do a speaker, you can replace the audio part with a simple stereo DAC. This part number of analog devices is actually something we tried for the stereo use case. And if you go to the right side, this is a diagram of our own imagination. You put in a higher end audio part with DAC, several DSPs, and several microphones. And this can also allow you to design an earbud with advanced ANC where you have microphones placed around the product. The point here is that you can maintain an application which will behave the same way and have many of the common features regarding user interface. You will have the LC3 codecs, which is standard, and the Bluetooth features implemented in the 5340. And that can be used as a base platform where you have the same Bluetooth functionality, but you can diversify products based with different audio codec parts. So let's have a look at the NR5340 audio decay. First on the front. As the name suggests, this is based on the NR5340 SoC, which you will find here. As usual, we include the needed passive component in the square to give an indication about the form factor and the final design. On the top, you'll find the codec part from Cirrus Logic, the CS47L63, and the output is here in a headphone jack. So this is actually a headphone output. There is a line in for input, audio input, which also goes to the Cirrus Logic part. Then you have the chip antenna and an SVF port for radio measurement. The power system, we have the Nordic NPM 1100 PMIC with related associated passives. On top here, we have pins to do current measurement, which you can use our PPK2 to do. And you can also, for this, you get the power on different rails. So you can get the total, and you can get the rail to the NR5340 SoC and the rails that goes to the Cirrus Logic part. So you can see the contributors from the various parts. We have user programmable LEDs and buttons. Some buttons have labels like play, pause, and volume, and that is what they're being used for in our example. There's also a multicolor LED on the side that will light up this plastic in the middle here. On the back side, you'll find the battery connector. Here is the mentioned RGB LEDs to eliminate the logo. We also have a digital microphone that is connected to the NR5340 SoC. We have a zero-wire debugger port, and we have a USB port to power device to do programming, and it also works as an audio input. So if you want to test the audio setup with the best quality, you can do that by connecting it to a computer and use the board more or less as a sound card. The NRF5340 audio decay can be set up and used in various topologies, and it all depends on the software on the kit. And there's one application for that, but they can build, you can set the compile time what you want to be. So you can set it up as a dongle, which means you connect it to USB, and the sound will be played through the USB interface and transmitted. It could either be connected or broadcast. Second, it could be a true wireless earbud, where you have mono output, and you can use the microphone as input to transmit back to the central device. You can also set up to be a broadcast receiver. That's a different configuration setting, but it can find and listen to a broadcaster and play the music. There's also a stereo headset setup, in which case you need to connect an external DAC or codec to the dedicated pins, and that will give you stereo output and microphone input. The LE Audio software solution is available in our NRF Connect SDK. It is available now in main, and it will be officially supported from the next official NRF Connect SDK release. You will see the architecture in the diagram. So the network core will contain something called the LE Audio controller for NRF53. So this is a binary image, a hex file that you need to flash the network core. It's important to note the name. It is different from the software controller that is the standard support for Bluetooth LE from Nordic, and it's different from the Zephyr controller, which is part of the Zephyr RTOS. This is the name you want to look for when you want to look for the controller to qualify in your end product. On the application core, that's where we run the Bluetooth host. As in RSDK, we use the Bluetooth host from the Zephyr RTOS. And this is no different here. All the features are imported and we use it as is. The LC3 library is delivered as a linked library, so that's something you link into your application. This needs to be licensed, so in order to get access to this, you need to enter an agreement with Nordic Semiconductor to get access to that library. Otherwise, there is also support for SBC, and if you cannot sign an agreement, you can still use the rest of the solution with SBC. Then we have the LE audio profiles. These are implemented as part of the Zephyr RTOS. That is where you'll find them. They are currently being completed, and we are all still waiting for Bluetooth SIG to adopt the final ones, but most are available now. Then we have an application on top that ties it all together, implements use cases such as wireless earbuds or stereo headset. And so it defines the behavior, and it's a good starting point to design your own products. The application example is called nRF5340 Audio, and it's made for the nRF53 Audio DK. All the use cases and topologies are supported. So you have the USB dongle, headset, earbud, and broadcast receiver. Which one you want to be, you decide the compile time, you compile the image and flash it, and then you can run it. Then we have the audio profiles. They're implemented as specified by Bluetooth SIG to be used by, and that's being used by the application example. The LC3 codec is provided as a library. We have a Bluetooth qualification with the QDID, and you can use this QDID to reference in your end product listing. SBC is available if you want to use the solution without signing an agreement. You can also use it to compare quality between LC3 and SBC. LC3 is distributed from a different GitHub repository, which has credential control. If you need to access the LC3, you first need to sign a license agreement, and then you will be provided with access to this GitHub repository, and you can download it from there. Bluetooth host, there's not much to think about there. It's part of the Connect SDK, and you use it as it is. The last, just to mention again, there is a Bluetooth LE controller that runs in the nRF5340 network core. We distribute this as a hex file. The reason why we distribute it like this is that this controller contains a licensed solution, but with the binary file has a perpetual license. There's no agreement to sign for you as customers. You just download it, and you have the right to use it for as long as you want. Nordic has covered everything else. So this brings us to the end of our introduction to Bluetooth LE audio, and I would like to summarize the points that we have been through. We've seen that classic audio has a number of limitations that cannot be easily overcome by simple evolution. And we've seen how Bluetooth LE audio is addressing these limitations. LE audio comprises a number of important updates in Bluetooth. So we've been through Isochronous Channels, which gives multi-stream audio transfer. We have talked about the broadcast audio mode for audio, which is completely new. And we have talked about the LC3 codec, which is a new codec which gives no compromises on performance and efficiency. It gives everything. And we have seen a new profiles which is designed for new and existing use cases with greater flexibility in mind. We explained why NR5340 is the SoC of choice for audio applications. And we've shown you the NR5340 audio decay and the contents of the NR Connect SDK related to audio to get you started. So with that, I want to thank you for your attendance and wish you the best of luck with your next audio project.